respected teacher, MD Sadman Sakib. Our group name is Five Forces. Now, I would like to introduce my group members. Asif Alamin, MD Shakil, Kamrul Islam, Sakat Hussain, and me, Sabir Hussain. The last three digits of my ID are 391. Today, we are have to present our topic, traveling salesman problem. Now, I am going to start my part of my presentation. Introduction. The traveling salesman problem is a classic optimization problem. It is widely studied in computer science, artificial intelligence, operation research, etc. The main goal is to determine the most efficient route among multiple locations. TSP is important because it is represent many real world optimization problems. Next, problem statement. In the TSP, a salesman is given a set of cities and the distance between each pair of cities. The salesman must visit every cities exactly once and finally return to the starting cities. The objective is to minimize the total travel distance, cost, or time. The challenge increases rapidly as the number of cities grows. Next, graph representation. Cities are represented as vertex or nodes. Path is distance between one node to another node, and the and it is represented as age. Age is weighted represented distance, cost, travel time. TSP is usually modeled as a completed weighted graph, and the solution is a minimum cost Hamilton cycle. That brings me to the end of my part. Now I would like to invite our group member Sakat Hussain to continue the presentation. Thank you.
Thank you, Sabir Hussain. Today I am going to talk about the traveling salesman problem or TSP, which is a well-known optimization problem in computer science. Okay, application of TSP. And logistics, where delivery companies find the shortest route to deliver a good efficiently. It is also used in airlines and delivery scheduling to optimize travel paths and reduce cost. Another important application is circuit board and chip design, where TSP helps minimize ring length. Additionally, TSP is used to robotics and automated navigation to plan efficient movement paths. Okay, then types of TSP. Symmetric traveling salesman problem STSP. In symmetric TSP, the distance from city A to city B is exactly the same as the distance from city B to city A. This means traveling in either direction costs the same. You can imagine this like a two-way road with a no traffic restriction. Because of the symmetry, the graph used to represent the cities is undirected. Symmetric TSP is simpler to solve compared to other types and is often used to theoretical studies and basic route planning problem. Example, like if traveling from Dhaka to Chittagong costs 250 kilometers, then returning from Chittagong to Dhaka also costs 250 kilometers. Then asymmetric traveling salesman problem ATSP. In asymmetric TSP, the distance from city A to city B is not necessarily the same as from city B to city A. This happens because of one-way roads, traffic condition, road slopes, or weather effects. Traveling in different direction may have different cost because of the graph is directed, meaning direction matters. Asymmetric TSP is more realistic and complex, and it is commonly seen in urban traffic system and airline routing. Example, like going from city A to city B might take 20 minutes, but coming back could take 35 minutes due to traffic or road rules. Why this difference matter? This difference matters between symmetric and symmetric TSP is important because it changes how algorithm work. Some algorithm work well for symmetric TSP but need modification for symmetric TSP. Okay, next slide. Our next topic, our approach to solve TSP. Several approaches are used to solve TSP. The brute force method checks all possible route and guarantees the optional solution, but it is very slow. Then greedy algorithm are fast but may not give the best solution. And dynamic programming, such as the held cap algorithm, improve efficiency for large problem. Approximation and mathematic algorithm are commonly used. Okay, thank you. Now I want to call the next presenter, MD Kamrul Hussain.
Thank you, Shagat Hossein. Uh, our all member are explain how to a short path going to a starting place to another place. Now I am applying a algorithm, boost first algorithm. You can look this picture. There have a different kind of place, and there have a array, different type of place array. You look this picture. A person are going to a place studying place to different kind of place, and at a time he also in his journey and studying place the like A to B to C to D to A. So which path is going to this person are short and easily traveling. Next. So there have an example like A, B, or C, different type of, different place, different location, and different distance. So we can apply a different type of algorithm, greedy algorithm. There have a four algorithm we can apply, but this one algorithm are A, B, D, C, and A. There has a minimum cost path. Next. So we can apply also a bootstrap algorithm. So how to working this process and this algorithm. So we can take a different type of place in array there, and then next image you can see a 3D in 3D visual. Then we can when we can apply this algorithm, the all different are easy path they also calculate, and then he also give me a shortest path, which path to which path is easy for going to this process. And all our process we can see there have 95, 80, 80, and we can last we can calculate the final path is 80. So we can start. So first of all time we need to fix start city, then apply our process, then calculate also minimum cost and cost efficient tool. Then next. So when we can apply this algorithm, then with time and space complexity. So time complexity, the which path first we select, these all path are around which time we need. The algorithm rounding time including inserting with the input size like n if the number of the element double, the time required also round double. So space complexity will also which space to where we can go. The algorithm needed the extra memory. All are selected memory selected place we save in this place. The also grow the library with n so as the strong intimated result. So why boost force algorithm implement in this boost force appointed in the traveling salesman problem, that's TSP. The algorithm treats all the possible premium of the city, the number of the possible rotate on n. So the time and space complexity also means the which path we can apply and which path we can go the short time and short space. Thank you. Our next member explain.
Assalamu alaikum everyone. I am Asif Al Amin. Last three digit of my ID is 489. Now I will explain the working of the traveling system. Traveling salesman problem using the brute force approach. In this part, I will focus on the pseudocode, its Python implementation, and the corresponding input and output. Pseudocode. First, let me clearly explain the pseudocode of the traveling salesman problem. The function TSP is defined. TSP distance is defined, where DIST represents the distance matrix between cities. We begin by algorithm we begin by initializing minimum cost to infinity. This helps us compare all possible routes efficiently. Next, the algorithm generate all possible permutations of the cities. Each permutation represent a complete tour that visit every city exactly once. For each permutation, the cost is calculated by adding the distance between corresponding cities. After reaching the last city, the distance back to the starting city is added to complete the tour. If the total cost of the current route is lower than the previous route minimum cost is updated. After evaluating all permutation, the algorithm return the minimum cost, which represent the optional solution. Now let us move on the Python implementation of the same algorithm. In this implementation, we use the permutation function from the itertools library to generate all possible city sequences. The function TSP takes the distance matrix as input, and the cities are represented using their index value. We initialize minimum cost with infinity and best path as none. These variables help us store the shortest distance and the corresponding optional route. For each permutation, the total cost is calculated by summing the distance between consecutive cities. Then the distance from the last city back to the starting city is adding to complete the cycle. If a route with a lower cost is founded, both minimum cost and best path are updated. Finally, the function returns the minimum cost along with the optimal path. After understanding the pseudocode and implementation, let us now examine the input and output of the algorithm. The input is a distance matrix where each element represents the distance between two cities. A value of 0 indicates the distance from a city to itself. In this example, 4 cities are considered and the distance between every pair of cities are provided in the matrix. This distance matrix is passed as input to the brute force TSP algorithm. The algorithm evaluates all possible routes that visit each city exactly once and return to the starting city. After checking every possible combination, the output shows that the minimum cost is 80. It also displays the optimal path, which is A to B, B to D, D to C, and C to A. This clearly demonstrates how the brute force approach identifies the shortest possible route. With this, I have clearly explained the pseudocode implementation and input and output of the traveling salesman problem. Now, I would like to invite MD Shakil, our last group member, to conclude the presentation.
Assalamu alaikum. I am MD Shakil. Last three digit is my ID is 484. Now I presenting the slide. My topic is advantage in firstly, the approach is very simple and easy to understand. The algorithm follows a straightforward logic by generating and evaluating all possible routes between cities without using any complex optimization technologies. Secondly, the brute force method grants the optical solution. Since every possible path is examined, the algorithm always identifies the shortest and most efficient route among all available optics. Finally, the approach is suitable for a small database. When the number of cities is limited, the brute force method performs efficiently and produce highly accurate results. The next slide is limitations. Limitations of brute force approach. Despite its advantage, the brute force approach has several important limitations. One major limitation is its very high time complexity. As the number of cities increases, the execution time grows extremely fast, making an algorithm inefficient. Additionally, the brute force approach is not suitable for a large number of cities. Evaluating all possible routes becomes impractical when the input size increases significantly. For moreover, the method is computationally expensive as it requires a large amount of processing power and time to handle bigger problem size. My next slide is conclusion. In conclusion, the traveling salesman problem is a fundamental optimization problem and has many important real world applications such as logistics, route planning, and network design. Although the brute force method granted the optical solution, its high computational cost restricts its use to only small problem sizes. Therefore, for large scale TSP problems, more efficient and optimizing algorithms are required to achieve practical and time efficient solution. Thank you for your time and attention.